My name is Michael Keogh. I'm on a team called Production SRE at LinkedIn. My team is responsible for driving major incidents, monitoring strategies. I do have a funny accent. It's Australian. Please don't mistake me for being English. Member facing, member experience. We're responsible for operating. So I'm a member for Couchbase Virtual Team. All of us are part of the group, are basically owners of a Couchbase cluster. LinkedIn was founded in 2002 to one of the world's largest professional social media networks. We have 30 offices across 24 countries, available in 24 languages. 450 plus million members, billions of page hits per day, hundreds of thousands of QPS. LinkedIn started as an all Oracle shop. We still have a fair bit of it around. While Oracle is fine for writes, read scaling is a larger challenge. As we went through the hypergrowth phase of the business, scaling challenges pretty important fairly quickly. But we saw that Couchbase had some distinct advantages. Simply replace Memcache, built-in replication and cluster expansion, automatic partitioning, extremely low latency, production and staging, 148 buckets, 3,000 hosts, 10 million plus QPS. So the largest cluster we have is 72 hosts, buckets with about 1.4 billion documents. We have a cluster that does 2.5 million QPS, which is queries per second, which is absolutely awesome. So firstly, simple read-through cache. Set up a Twitter account, so if you share something on LinkedIn, it tweets out to your Twitter. We need to store those credentials, scale our systems really easily. We don't have to go and buy more expensive hardware to run several databases. Second use case is counter stores. The main use case for this at LinkedIn is our anti-abuse and anti-scraping system. It basically counts how many pages you as a member or a user of LinkedIn have viewed in the past 24 hours. Our systems are staying protected. Public member data is not being scraped. Use case where we need to basically deduplicate data.
The email system is sort of consuming these messages. We go and check in Couchbase if we've already consumed that message and sent that email.
And the final use case is a source of truth store for internal tools. SREs love Couchbase at LinkedIn. It's schemaless, so we have the ability to go and make changes and prototype. Notice is our auto remediation system at LinkedIn. So auto remediation jobs that are fired, all the different plans, the settings, traffic shift in. That's a tool I wrote, and it is a global traffic automation system at LinkedIn. How our traffic is distributed across our data centers. So our alerting system heavily uses this to work out should we suppress alerts or not. Then our availability monitoring views to do map reduces and get this data back out and run reports for our executives. So what is my QPS? What is my hit ratio? How many items do I have in the bucket? Is in memory? And how large is my disk queue? Where we deploy each of the buckets, what versions of Couchbase they're running, do we have failover turned on? We're going to keep expanding our use of Couchbase. We'll start to use Nickel, starting to look at using rack awareness as well. Is moving Couchbase into the LinkedIn standard deployment infrastructure.
Welcome everyone, my name is Clint Ricker, Solutions Architect in the Office of the CTO for Cisco. I work in service provider video, so Cisco's the leading provider of video technology to video service providers around the world. Running mission critical, very large scale deployments on-premise and as a service all around the world. Data sets in the billions of records doing some pretty high transaction rate. And then you say, okay, I need a way to do queuing, and I need a way to do discovery, and I need a way to do all the other sorts of nice fun things that you need to do to make your application work. You start deploying those technologies, and they start bringing along their own dependencies. Trim that down, and so that when we deployed, it was just simply a very bare-bone minimalistic stack of app instances in Couchbase. Now I'm going to just step through some of the common functionalities. Global distributed lock. So this form your lock document. You do an LCB get with a lock and a timeout. And if someone else says it locked, you're going to get a failure message back, and you know. Leader election. So this is used to have a dynamically dedicated master. So if you are the leader, if you refresh the document every few seconds, and you do that just by doing a replace on the key. If you're not the leader, then you try to create it every few seconds. And if you're able to create it, then that means you're the leader. So discovery service. So this is used to discover endpoints for specific services, supports basic load balancing, health check, etc. We have a document of the nodes that are advertising themselves under that ID. Each application instance pulls the document down, kills out anything that's stale in there, and inserting themselves into the document and then writing that back. On the discovery side, pulls it out of Couchbase. It has a set of nodes, randomly selects one to get load balancing across the set, and then talks directly to that node. Create a shared queue that's used across a set of nodes to queue up activity that's coming in. Adding to queue, very simple. Just form the queue document name and append. And that's going to be a get with a lock. Pull off a chunk of items and remove that from the queue, write it back, and then transactions. We do a lot of stuff that's very stateful. We are setting up policy sessions, bandwidth reservations on networking equipment. Overall operation fails, there needs to be cleanup. A transaction state record, and then a transaction log. You append your activity, each step of your activity to the transaction log record. Scenario where the transaction failed or timeout. Iterate through the transaction logs in reverse and undo each activity. Close out the transaction, whether it's successful or whether you had to roll back, by just simply deleting the two records that you created.
Hi there. Thank you very much for coming. At Cvent, we do online event planning. We have 1,900 employees, manage 1.4 million events. Those are conferences, meetings, sessions. We have a 1 billion market cap, and we've got a whole bunch of users that are just growing. A lot of us have a gaming background, and we've used Couchbase in our prior jobs. Memcache compatibility, great clients. It's really easy to administer. I'm a developer. I want to do some DevOps stuff, and here you go. Here's Couchbase. Certainly scalable. Schemaless, the indexing. We've got a lot of standard data, airports, hotels, all this stuff, right? Throw it in Couchbase, and it's readily available. Again, moving forward, it's becoming a primary source of truth for a lot of our data, but NQL is easier, and a lot of our developers having that SQL, traditional SQL training, they can walk right in, start developing on Couchbase. 8 clusters, 215 plus applications. What is a microservice? It's modular. It's decentralized, it's scalable, and it's got a well-defined interface, right? It's basically a simple application. A lot of these microservices depend on each other as well. We've got pretty much a one-click creation process for our services, able to authenticate more users quickly, scale out the authentication service, right? Built-in integration tests as well as unit tests. They're connected, so it's easy. We have got a very standard process for service registration. When the Java client got updated to version 2, everything broke. We were really fortunate to have this library. To deploy views, generally we recommend they do that ahead of deployment of the application so the views can index. Jenkins does that for us as well. NQL, that's something I'm working on now. I talk a lot about best practices and managed schema. I provide a client, the native client I mentioned, configuration, service discovery. How do we enforce our best practices? When we use the VIP, the client connects to the VIP, picks a node, and it gets back the cluster map, feeds it back to the client. And then the client connects to all 3 nodes. And this was critical when we replaced all the hardware in our cluster. But now they connect to the VIP. The VIP's got the new cluster information. Everybody's happy. That's the secret sauce. And this is a standard microservice deployment time. Obviously, the cycle starts again. I'm going to show you how quick and easy it is to build a service, right? So I'm going to go to Jenkins, right? But I'm going to build a service bucket. We're going to use the data one. The Wizard of Oz stuff I was talking about. Bring up IntelliJ, a REST endpoint, get and set this particular entity. Run this local empty Couchbase node, and it's empty, right? So let's go to our service. We're going to say FlibertyGibbet, right? And the document is not found. And change this to a post. Here's the demo, and the entity is extensible. This helps with versioning, and we're going to post it, right? And it got created. If we post it again, it's conflicted. We do a get. The data is there, right? There's our data. And then we can go back to Couchbase, right? Here's our document, right? So here's the cluster health of our production node. Queue size and queue age. We had some failing hardware. We knew we had a problem. And how did we find it? We found it with this graph. Couchbase support was really helpful, actually. It's my goal to get all this stuff open source. It'd be great if we could build a community around this work.